Okay, good afternoon, everyone. Hope you guys are doing well. So today we are going to talk about exercise 10 problems, and specifically we'll be covering document stores, and mostly we'll be focusing on MongoDB. Before start, I'd like to first mention that I've discussed with the TA team. So RDD queries are not optional, they are mandatory. So in one of the sections, you've got to use RDD APIs. Sorry about that, but yeah, that's one of the requirements I'd like to mention here, right? Basically we'll have, I think, two sections of queries you need to write, and in one of the sections you need to use RDD specifically, and in the second section you can either use Sparse SQL or just the functional interface. Either you write SQL queries directly or you use the APIs. Okay. Yeah, so that was just the leftover from last session. And yeah, specifically in this session, I will compare document stores with relational databases. We'll look at the indexing, the system design, the references of MongoDB. And finally, we'll conclude with some comparisons between key value stores and document stores. Okay. And also, there are lots of practical questions and queries in the notebook, and I would highly recommend practicing, and as usual, right? It really helps with your understanding. All right. Okay. So first, I'd like to first motivate, as usual, to give you a bit of a context why we're introducing another database, right? It's almost being a database course. But the reason being, document stores have their own advantages in terms of managing data, right? As I've discussed before, prior to the start of the session, why MongoDB is so popular, right? So many companies are using it. And the primary reason is just so simple, right? Like the APIs are well documented, and it's very easy to integrate into your system, in your code, or just your data analysis using the API. And the fundamental reason is that it basically imposes virtually no restrictions on the type of operations you can do on your data. Right, so you're free to do updates, read, write, whatever you want, right? You don't have the kind of restrictions that as you do with relational databases. But this is really sometimes quite bad for maintenance, right? So that's one of the downsides. But apart from that, so especially when you are during a system design interview and you are being asked about MongoDB, then it's basically a no-brainer because it just works, right? And they wouldn't typically ask you about maintenance and so on. So yeah, that's the go-to solution. And the second reason would be the flexibility in creating schema, right? I think nowadays software is being updated quite frequently, and your data model is also likely to evolve together with your application, and flexibility is a key. And specifically, for example, like nowadays, I don't think anyone is using a fax machine, right? So if your customer were to have, fax numbers years ago, and now you're not having that. By using MongoDB like document stores, you don't need to worry about, oh my gosh, I need to upgrade my database or migrate to another thing or totally change my schema and so on, right? You don't have the headaches. And the third reason is performance, right? Specifically on write for document stores. They are typically optimized for large volumes of updates. So if you are seeing a question about which technology you should use when it comes to a large number of updates, writes, and you should typically prefer document stores. But for MongoDB, it's a bit half-hearted because it's under the hood still using a B tree, right? This is very similar to the relational databases we've been dealing with. And for B-tree, as we've talked about, it's really prioritizing a read throughput over write. So, but still, like for MongoDB or other relational document stores like CouchDB, they are very highly optimized for writing documents, the write throughput. And also, they are using a very efficient document-oriented format, in this case, the BISON format, binary JSON, and this can give you efficient I/O on documents. And also, there's no schema locking, right? You can even not providing any schema at all. So, but here later we'll be looking at how this can affect the data integrity we've talked about. Oops, if I can spell. Yeah. So, but for MongoDB, by default, it's using eventual consistency. So when we're looking later at the system design, we'll know like why eventual consistency is the default for MongoDB. But of course, you can increase the consistency levels by configuring the system later. Okay. And the last one is data locality, and this it's really caught me by surprise why we can still have data locality in this scenario. Any ideas why like document store can provide us with data locality compared to relational databases? Think about the data model it has. Yeah.
You mean with the nested stuff can be stored in the same document, so when you access one document, you can access basically all the information that you have regarding that document. So.
Right. Exactly, yes. So just to quickly reiterate, what he was saying is that, yeah, so basically the data locality comes with the nesting related fields together. So for example, if I have a record of myself and I have a bunch of other activities you want to log, and instead of storing them in a separate table, I will just nest those activities in my the single record. So this is a quite different like attributes compared to relational databases where we model this one-to-many relationships with joins, right? We have a bunch of joins. Maybe those joins will be over network connections, right? For example, and this could incur very heavy overhead, right? And by having data co-located together, you will have better data locality. Okay. Any questions at this point? No. Yeah. Later we'll be looking at some one-to-many relationships, and but basically we're using nesting instead of joins to model one-to-many relationships. Okay. Alrighty. Moving on. Another interesting fact is that it provides a bunch of options in terms of the indices you can use, right? Apart from the primary index, you can have a bunch of secondary indices, and you can even have multiple types of those indices, right? For single field, you are free to choose from all this like B-tree sorting, right? This is by default, and you can choose hashing, hash partitioning, and multi-key, basically if you have a nested array, for example, I have a semester of my grades, a list of grades, and you can even use those grades as keys, right? Something you can't do with relational databases, and something found very peculiar. So this geospatial stuff basically is a multi-dimensional key, and you can also index by text, so in the strings directly. Okay, and if you want to, have compound keys, you just specify multiple fields, right? You want to be indexed on, and you specify the types of index you want to have on each of the field. right? And this really gives you, and this is also one of the reasons why it's so popular, because for providers or for application developers, they can really customize the database based on their needs, right? So they can tailor the database towards their applications or workloads or queries. So if you have a specific queries you are executing millions of times per day, then yeah, you can, if it's a range query, you better use B-tree sorting. Question? Yeah.
Compared to which systems is this special? Because like Postgres also, I think, has all of these indices.
Right. So the question is, why it's so special in terms of the indexing options, in terms of the indexing options MongoDB can provide, given that other relational databases like MongoDB can provide you with similar options as well. That's a really good question. So I think what I wanted to emphasize here is that the flexibility still. So you can still have similar types of indices, but here you can really have multiple indices on different fields or even on the same field. But for relational databases, it's much more restricted. For example, it has to first guarantee the integrity and the efficiency of the updates of the indices. So there are a lot more things and restrictions you need to consider. Here, you can just pull up a collection and set how many numbers of indices you want to set directly on which number of fields. So yeah, it's much more flexible in that sense. But in terms of performance, it's not as good, I have to say. Yeah. Right. But of course, the downside I haven't mentioned here is that, well, the data model is very flexible, but the coring option, so in terms of how you can do joins, yeah, it's not as flexible actually, because it's very tailored to specific workloads. So if you want to have very specific queries, like multiple joins, then, well, it's going to be difficult over multiple collections and databases. Okay, a collection here in terms of, in MongoDB's term is basically a table, right? A database is a database, right? Questions? Yeah.
Why do we need the primary index, like using the MongoDB? It doesn't have like the underscore ID field.
Right. Yeah.
Like how useful is that actually? Because I don't feel like I'd ever do a point query with the underscore ID. Like,
right.
Is it visible to the user?
Right. Good question. So the question is, why do we need a primary index? And for example, in MongoDB, it's by default the underscore ID, and is that visible to the user? So, so the primary, it's necessary because it relates to the underlying database engine, so or the storage engine. So one layer below MongoDB, how it stores files on disk. So at the end of the day, those JSON documents or files you need to serialize to your disk. And for the reason why we have the B-tree index comes for free, well, not for free, but by default, is that the I forgot the name, but the underlying storage engine used by MongoDB, MongoDB built on which is using the B-tree. So for that database to work, you need to have a primary key to index and to store fields very efficiently. And later, I think later we'll be looking at what other methods or what other benefits or functionalities these default keys can provide. For example, sharding, we'll be looking at those kind of things will by default use this primary key if you are not specifying, which typically users don't care. Most users don't care. So yeah, it serves a multitude of functionalities we'll be looking at
for
later.
example, if I make a query,
yeah,
like at no point will I use the primary index. So if I make a query that's like I'm looking for name equals vehicle,
right.
Like, I will never use that like primary index to speed that up. That's just in the storage side.
No, you're right. We are not going to use it because if we don't have any other index, any indices, then we will just do a scan. But the thing is, the way you do scan, the reason why you do scan that we are taking for granted, for example, we're searching for Philip, then that's way the way we can scan is because it's thanks well, we need to thank the primary index, because that's how the data is organized on disk based on the primary index. So we are scanning, still the scanning is based on the primary index, because yeah, that's the underlying storage. But good question. Yeah. Right. A question.
So do these secondary B trees store the IDs of the objects? So like the leaves of the B tree, they store the ID of the objects, or do they store, what do they store?
Right. Thanks, Philip. The question is, do they store? Does the primary index or the B tree store the IDs, the primary keys, right? The default keys. Is that the question?
The secondary, the B trees for the secondary images.
Right. Oh,
the
I see.
leaves store the IDs that then will be used to actually traverse the primary B tree and then to know where to locate the document file actually.
Right.
Or it's just, it's immediately like kind of information of where to locate the file with the document.
Right. So if I understood correctly, the question is, do other like secondary indices store, for example, the primary key or the default keys? So I'm not sure about the actual implementation, but I would assume no, because I don't see a purpose for that. Because, for example, a B tree, another B tree on another index or another field, right? And on top of that, B tree is just a data structure. It's like, I don't know, it's like the inode on Linux, right? So they are basically numbers, and you are sorting them and creating this kind of tree structure in order to index into the data node. I think as long as you can access to the data node at the bottom, there's no need to replicate other data on top of the indices. So yeah, that's my guess, I think. But you're right. So I think the only thing it needs, or if it doesn't store anything else, is the keys is indexed on. Yeah. So yeah, good question. Alrighty. Okay, moving on. So next we will be looking at the indexing in MongoDB in more detail. So here I'd like to highlight 2 points. One is the multi-key index with compound keys. Right, sorry, here I think it should be compound keys. So specifically, say we have a schema I stole it from the exercises. Say we have the restaurant collection or the table, and we have the address field, bara, cuisine, grades, name, ID stuff. And then what we want is that we want to create an index on both, a compound index on both the coordinates and grades. Is that possible? So this is the coordinates, and these are the grades.
No.
Why?
Because they're both arrays, and I think you can only have one array, I believe.
Yes. So this would be a common question in the exam. So basically, because of the system's restriction, as you can see, you can imagine like if you are having multiple array indices, it's really hard to determine the ordering. Right? So here you can only have maximally one array field. Okay, so here both the coordinates and the grades are arrays. That's why you can't do this. And another is that, another intricacy here is indexing on embedded fields. So here what I'm showing here is that we are creating an index on the scores. So this is the nested field of the grades with a descending order, right? And the question here I'd like to ask is that which one of the queries below would benefit from the index we just created, or both of them, or none of them. So here we have the scores, and we want to find the scores equal to 11 or the scores greater than 11. Okay, so I'll review the answer. So this is quite particular. I think so in MongoDB, if they ask this kind of questions, you all just check only the equality matching of nested field or can benefit from the index created on this embedded attributes, right? So in this case, only the second query can benefit. The first query can benefit from this index, but not the second. So it's either not equal, or matching strings can benefit from this index.
Why? That makes no sense to me.
Honestly, I don't know. I didn't find any resources. I guess I think you can only sort within a document, and when you are accessing like the nested field over multiple documents, I think it's a physical constraint as to how you can sort it. Like it's really hard to sort them across multiple documents, and it's only effective when you are accessing them within a document.
When you create an index on grades.score,
Yeah.
like does it unpack those values into an array of integers?
Good questions. Yeah, the question is, when we are indexing, say, on scores, does the indexing engine unpack the whole thing and extract this field out?
Yeah, like would it unpack it to like 11, 17 in one array?
The question, well, the answer is no. They won't unpack everything and peel everything out. Like the documents. The only thing changes when you are changing the indices is the data structure on top of the collections. They will never touch the data in order to match the index. So they will be stored as they were, but the only thing I guess is that I think one of the reasons for the restrictions is that because they are still nested together, stored together, so you can't do much with the sorting across.
I'm just wondering if like a nested to grades.score.
Yeah.
Would that count as using up your one array field allowance?
One away for what? Sorry.
You know how the column number 1 says you can only have one array field in the index.
Right.
I'm just wondering if grades.score, which is nested inside
Mm-hmm.
an array, like meets that quota.
Sorry, I still didn't get your question. Sorry. Are you asking whether we can like extract the field out or?
Like if we create an index on coordinates.
Yeah.
That uses up the quota of having one array index.
Oh, right.
If you do grades.score, that's still kind of an array. It's just nested inside, but it's still got that array structure.
Yes.
So would that use up the quota?
Oh, I see. Yes. So the question is, if we're indexing on grades, would we use up like this maximum quota of having one array field? Yes. So in this case, we're also indexing on here. So as long as it's an array, yeah, it doesn't work. I'm not sure if you can have like things like within this field. I'm not sure, but yeah. But as long as it's an array index, a structure, regardless of the field, it will use up the things. Yeah. Basically, if you can think of it as creating a comparator, using these arrays, you need to find the partial order within the elements, stuff like that. Yeah. As long as it's impossible, then yeah, it's not doable. So yeah, just to highlight here, so it's only effective. If I can spell. No. Effective on equality matching. All right.
So it doesn't matter whether it's ascending or descending index in this case?
Here it doesn't. Yeah, here it doesn't. Yeah. Right. Moving on. Okay, questions. Sorry.
I'm just a bit confused because looking at the solutions,
Right.
there seems to be one solution for one of the questions about indices from exercise 10 where they actually use a created index on grade and grades.score. So I don't know whether that's a mistake or if it's actually like possible in some way to use two of those nested fields.
Right.
in business solutions.
Thanks for checking. Yeah, thanks for the question. I think I can recall the question. I think the index was on grade, right? Or
No, it's on grades.score and grades.grade.
right.
It's question 8 from task 4, question 8.
Great. And what was the question?
The question was write and index the speed of the following query,
Yeah.
and then basically they propose in the solution to create an index on grades.score and grades.grade, and they say, okay, this is not very efficient, but I mean, I assume from the solution that it would be possible to create this, but I didn't actually try it.
Right. And what the query is, I wonder? Is that an equality or a range?
The query, let me check.
It's a range and
Yes.
equality.
Right. Okay, that's expected. So basically, you are creating an index in a nested field, and you are querying using a range query. In that case, I would say it's like creating a hash index on a nested field, and you are querying with a range query. That's why it's very inefficient, because you are basically checking equalities using that index. But I think the reason why it still helps is because I think it's a bit better than scanning in that sense. Yeah, so.
Yeah, I mean, I understand why it's the solution to that question, but you said before that you couldn't create, or maybe I misunderstood that, but I thought you said that you couldn't create an index using 2 of those nested fields.
Oh, sorry. I was saying that you can't create, you can create, so there is no restriction on the number of indices you can create on nested fields. There's only restrictions on the number of array fields you can have in a compound key. Sorry, so let me reiterate, yeah.
I thought that I mean, that was my understanding, but then I probably misunderstood that this would count as like an array field. If I take like one of those.
No, sorry. Yeah, by nesting, I mean here. You're nesting a document. So this is, yeah, sorry. This is an overloading of terminology, but this is still nesting, but this is an array. So this is very specific to array structure. So if it's a document, this is fine. If that makes sense. So you can create as many indices as you want on these nested fields, but as long as they are not arrays. So here you have an array as index, then you can only have one in a compound multi-key or compound key, if that answers your question.
Yeah, that makes sense. But then I just misunderstood what you said.
No worries. Yeah, I think the terminology is a bit confusing. Yeah. All right. Okay, question.
I was wondering why
Yeah.
can't you create an index on 2 arrays?
So the question is why can't we create an index on 2 array fields, for example? So this is referring to the first restriction. Yeah, let me think. Yeah.
I mean, I'm reading the answers. And
Yeah.
It says, like, the number of index entries you can would explain. So I think it is possible, it's just things that you do massive.
Yeah, that's a really great point. So, yeah, I like the first reason as mentioned is definitely it blow up your like data structure for your indexing, and secondly, it makes the comparison more difficult, I think. So if I have 2 arrays, determining the partial order is much more difficult, and there are more conflicts. Yeah, I think it might cause conflicts. Yeah, but that's my guessing. Yeah.
I was also wondering, how does the like B plus tree look when you create the index for grades.score? Like, since like for one document you have multiple scores, like which one do you choose? Like when you're comparing documents to each other?
Yes, so the question is, so when we are indexing on an array, and what would the B tree look like? So one thing I skipped is that technically MongoDB is not using a traditional the traditional B tree. So it's like a modified version of B tree, so the underlying storage engine. And getting back to the question, actually it doesn't really matter like what kind of keys you're using. So in traditional B trees, there will be, as you said, only one number. And here in the modified version, the whole thing will be a key. And the only thing that matters is the comparison between them. As long as you can determine the ordering between two arrays, then it's fine. Yeah.
Like for when you create an index with grades.score, like how do you determine the order since you can have multiple scores?
Good question. Good question. I need to double check. Yeah, I need to double check. I'm not sure if it's sorting first and then do the comparison, which is sensible, or yeah, I'm not sure. Question?
I was looking at the MongoDB documentation.
Yeah.
And it seems that when you have a multi-key, it takes each element of the array separately.
Right.
And then, so it basically explodes all the values in one big array, and then it does the indexing on the single elements of the array.
Wow. Okay. That's unexpected.
It doesn't make sense. I don't know.
Yeah, in that case, I really don't know like how multiple how multiple index trees work together in that case. Yeah. Yeah, I need to read up on that. Yeah, but good question. Yeah, thanks a lot for checking it out. Yeah. All right. Yeah, you guys are really pushing my own boundaries, but that's good. That's good. Yeah, but I will definitely look it up and get back to you guys next session. Yes, another one is matching prefixes in compound indices, and this is one of the common questions you can expect in the exam. So here, what we have is that we are creating an index. We are creating an index, compound index on 3 fields, right? Bara, cuisine, name, and then the question is which one of the queries can benefit from this compound index? Right, and the method here, I think I will introduce later. So what about A? Good, right? A can benefit from it. B, good. B,
Could you,
no.
could
Right.
A benefit if it would have been sorted in decreasing order as well?
Yes, you can.
Okay.
So the question is, can query A be can benefit from the compound indices if it was sorted in the descending order? The answer is yes. So the reason why A can and B cannot benefit from the index is that, so basically for this kind of questions, I would just check if this query is a prefix of the compound key, so are basically matching the prefixes, or the exact inverse of the prefixes. So in this case, for example, the prefix, where's my pen? Yes, so the prefix here, bara, is the prefix of this compound index, but cuisine is not, okay? And the reason for that is that, so the ordering, although it's counterintuitive, but the ordering in the fields matters, right? So what MongoDB would do is that first it sorts the whole collection based on barrel, and given the sorting of barrel within the sorting fields, so if there is any equality, it will sort cuisine and name subsequently, right? Question?
Maybe that's kind of a stupid question because it also asked about the actual implementation, but
All right.
why can't, so I know that it's not possible, but why can't the second query also benefit from the index? Because in my understanding, I mean, of course, the speed up wouldn't be as much as for an actual prefix of the index, but I still feel like it could at least to some extent benefit, because basically, I mean, I would have to check like for the entire order of
Right. I think that's a really legit question. It's not stupid at all. I think I also had the same question. I think the key here is understanding the ordering. So when you are sorting first on this field, so on borrow, then sort based on that sorting order, you are sorting cuisine. The result is that the ordering is majority on a borrow. So the only ordering you have on cuisine is in cases where you have like equalities between two collections. So if two collections, the ordering between two collections in terms of borrow doesn't matter, then it sorts based on cuisine.
But
Yeah.
just like in an imaginary data set, would that were the case that a lot of the actual documents would have the same value of borrow? Would it bring like some sort of speed up there or not at all?
Right. Yes. So the question is, in real scenarios where we have, say, like only a couple of borrows and we only have 5 borrows, and wouldn't that be helpful in terms of finding the right cuisine? Because you have lots of documents having the same borrow. Yeah, it's quite counterintuitive. Actually, for one of the later queries, I also thought it should be beneficial, I have to say. Yeah. Honestly, I don't know. Yeah, I'm not sure. Yeah, why it's not beneficial. But yeah, that's a good question.
Why
Yeah.
it's not beneficial to what?
Why it's not beneficial when, for example, we have lots of common barrel, and the documents are pretty much sorted by the second field, for example. Yeah.
It's just not been implemented.
Yeah, but that's a really good question. I will come back to you in the next section. Yeah, in the next session. But yeah, that's also one of the doubts I have. But yeah, so what I'm talking about here is how you do the exams. Okay, so if you encounter this question in the exam, yeah, please don't hesitate writing down that it's not beneficial. But I think that's a really legit question. I will look it up later.
You would have to still scan the whole tree because it's sorted on hamburgers.
Yeah.
Like you can't be sure that there's not like on hamburgers like the end of the tree because there's still a possibility.
Right. So I think in terms of asymptotic complexity, you've got to still go through every single node because the primary index is on the first field. The second field within each collection of documents, you can have a local speed up, but globally, I think asymptotically the complexity is still quite similar to a scan. So yeah.
It should be the same.
Yeah. So yeah, that's my best guess. My best guess. Yes. So continuing on. What about the third query? We have borrow cuisine. Yeah, good, right? So this is yeah, a prefix of this index. Good. This one we've discussed. What about borrow and cuisine, both in ascending order? This should be good. No?
It feels like it should be able to.
Yeah.
In a good way. If it's been implemented, it would work.
Should be able to do it.
It should be able to, but the answer is no. So by inverse, I mean exact inverse. So you can't have one inverse and another, well, you can't have one being the inverse ordering and another not. Exactly why, I am not sure. I need to look it up. But yeah, I think you can flip the index quite easily by going in the reverse order. But yeah, question?
Sorry, does the prefixing work as well with the inverses? So if I have this index here, I can do borrow as one prefix, which is a valid index.
Mm-hmm.
Then borrowing 1 and cuisine minus 1.
Mm-hmm.
Those are both prefixes, but if I do the inverse, do I also get the prefixes of that index?
You mean by indexing cuisine first?
So if I take the inverse, I get borrow minus 1, cuisine 1, and name 1.
Yeah.
And can I take all prefixes of that as a valid index as well?
Borrow being -1, cuisine being 1.
Yeah.
Yes.
Okay.
That would be a valid, yeah, that would be beneficial from the index. Yeah, so that's actually, I think, the F part. So for this query, you have exactly the opposite on both fields, and that would be beneficial as well. And for the last one, for E, I was also wondering, for this case, actually the primary index is the same, and the only thing you need to do is just to go inside the sorting and do some extra work with the cuisine, and I would expect some benefits of using the index, but no. Reason why? I need to look it up, but good questions, guys. But yeah, the last one is not, because it's not a prefix. So just to quickly reiterate, this is my way of doing the questions. First, you check exact matching of the prefixes. If you don't have the exact matching, you check the ordering. If the ordering is exactly both of them, all the fields are exactly the opposite, then this query would also be beneficial from the index, the compound index we just created. Okay? So the ordering of the fields matters. Okay. Right. Moving on. So next we will talk about the system design, under the hood, how MongoDB is dealing with the queries we send to it. So I think the overall picture should not be unfamiliar to you guys. So here we still have a driver program as we had in Spark. So basically this is where your application communicating with the underlying system through this API or the driver program. Okay, and once you send a query, say I want to find something, a collection of bara, then this query will be sent to the driver, and the driver will send the query to something called a Mongos. So this is, you can think of it as a query router. So it routes the query to different shards of the collection that you define. And yeah, so here we also have sharding, right? So here, this is the collection, say my table, and it shards based on here is the point. So if you don't specify a sharding key, it's using the default underscore ID. So here, the sharding is based on the underscore ID field by default. But of course, you can provide your own keys. You can specify your own keys.
Is providing a sharding key any different to having an index? Or?
Yeah, that's true. So the question is the sharding key any different from an index? Yes. So there are two different stuff. One is for storage, for the storage engine to handle how you serialize those documents to the disk. Another is for data accessing. So here, the ID is for data access.
Would it not usually make sense to have them be the same?
Right. The question is, wouldn't it be more efficient if we have them being the same? It depends. It depends on the type of queries you want to execute. So if your query matches the index, and you always say 1 out of 100, 99 times out of 100, you will execute that query, then you better, better say organize your shards based on that index. But if your workloads are very heterogeneous, then it depends. Yeah. Question.
No, it was only because that would make it even faster than having an index.
Yeah, that's true. So if you can, this is basically so-called the co-optimization or cross-stack optimization. So optimizing for a specific workload from the storage layer up to the query application layer. So if you can do that, you know the specific queries or the structure, then yeah, you can further optimize down to the bottom. Yeah. Question? No, okay.
Yeah, well, like the book said that the fields used to shard must be organized in a tree index structure.
Okay, right. So the book says that the sharding key has to be a tree structure. Sorry, the sharding index. Yeah. Okay, I think that makes sense. Right. Question.
How are these shards actually organized? So is it like all the documents with the same value of the sharding key will be the same shard, or will there be multiple documents with different sharding keys?
Right. The question is, how are those shards organized based on the key? So I think it resembles how we're dealing with the white column stores. We are talking about HBase. So it's basically a range partition by default. So say we have 1,000 documents, then the first 500 go to collection shard 1, and the latter goes to shard 2, stuff like that. But yeah, it depends on the policies you have. Yeah. Right. So yeah, these two images I stole it from them from the official documents. But basically, it shouldn't be. It should be very familiar to you. And for the shards, for each shard within each collection, you have this replication, right? So as we've talked about replication in HBase or other HDFS, you are replicating it for example, in this case, we are replicating it one single piece of data block, with one single piece of data to 3 replicas. The only thing different here is that MongoDB is using something called single leader replication. Can we spell? No. So what I mean by that is, so if you can recall in HDFS, if you have 3 replicas, there is practically no difference, logical difference between the three replicas. So whichever replica is closer to you, the HBase will read from that data and serve your queries with that replica. But here is different. Here you only have one primary replica. So they are not born equal. So this one is so-called the leader, right? And by default, the driver or the Mongos or the router, the query router, will always route queries to this primary replica. So it can do reads or writes, but all the reads and writes are served by this single replica only. And all the secondary replicas are taking the operational logs, or in MongoDB's term, is the all logs. So they are taking the logs and replicating the operations on their own, so that they can create a kind of a replica, or a duplication of the primary leader in case of failure. And they are communicating with each other via heartbeats as well. Okay. And yeah.
If the leader crashes, how they elect, what algorithm is the next leader?
Right. Okay. So the question is, what if the leader dies, right? What if the leader crashes? What algorithms? How do they elect the next leader? So typically, so that's a good question. So typically, you will also have something called an arbiter. So you can also create an arbiter, and you can implement a leader election algorithm inside the arbiter. So in the case where the primary fails, the arbiter will decide which one of these 2 secondary replicas to be elected to be the primary to serve the request. The algorithms can be pixels or can be other algorithms. It's flexible. It can be defined by you. But basically, it will create a new leader. Say this is the new leader.
So it's not distributed, it's just run directly on the arbiter.
Right. So the arbiter, I think, would be collocated. Yeah. But I need to double check the location of arbiter. Yeah. But what's the problem of this architecture? Yeah. Question.
sends a request to all the shards, and then the shards have the B trees to actually access the documents, or the B trees are stored in the router, and then it asks the shards based on the events.
Right. I would say what I'm talking about here is the storage layer, right? So the data structures like B trees are located or organized on a much higher level. So basically, when you are accessing the shards, either you've got the idea of where your data is located, or you don't know. So you need to scan all the shards. So basically, Mongols or the router would know based on the index where to access the shards. Otherwise, it will scan everything. Yeah.
So the B trees are in the Mongols at the sites.
Right. Nice. So it doesn't have any data but policies and data structures. Yeah. All right. So yeah, getting back to my previous question, what would be the problem of this scheme? Actually, this is also one of the reasons why some people go for other databases other than Mongo. For example, CouchDB. They have multiple leaders. So in this case, as you can imagine, if this primary dies and it only serves the request, it's the only one who serves the request, then you will suffer from a downtime, which can be quite critical. So you will suffer a downtime when electing a new leader because new requests can't be served at that time. And actually, you can, it's only when the secondary is up, being a new leader, the request can be served. But you can specify that in MongoDB, you also want to use other secondary replicas to serve your request. But in this case, you are risking accessing stale information because, maybe the operation logs have not been executed fully, stuff like that. That's why I was saying that by default, MongoDB is eventually consistent. Okay. Any questions?
How long does that consistency take? Like, are there any guarantees on the time it takes to reach consistency?
Right. Good question. I think if you have a collocated arbiter and there are two sources of latencies. One is the communication between the arbiter and other secondary replicas, and the replication process. So the secondary needs to bring itself up to date using the stacked operational logs. I think milliseconds, I would guess, yeah.
And just on that, that's okay. We said like writing to like MongoDB is better than writing to the your traditional database system.
Mm-hmm.
But it doesn't seem very load balanced. Like you're just sending it all to the primary when you're writing. Does it not just get congested?
That's a good question. Yes. So if you only have a single primary, right, a single leader, then your throughput is going to be bottlenecked by this single leader. That's why some people would configure other secondary to serve reads, not write, to speed up the reads, to increase the read bandwidth. But I wouldn't say it's much faster. It's faster than relational databases. It's definitely not. I think writing specifically for nested on a semi-structured data, probably it has a competitive edge, but for typical transactional queries, it's not. Yeah. Good question. Right. Okay. Moving on. Next, we will talk about references in MongoDB. So first, why do we need references? Some people still want to have normalized schemas. In that case, it's serving as like a foreign key. So if you have a reference, you can normalize your schema by referencing somewhere else. Okay, it's like creating a outside table. in some sense. And also, you can think of, for example, your logging, which most companies use MongoDB do, then the maximum document size is limited by 16 megabytes. And in that case, you might need to reference to somewhere else to circumvent this restriction. Okay, and primarily there are two types of references you can use. One is the manual reference, I call it. So basically, if you want to reference, say, the place here, the place here is inside of the people table, then you can just put the the other way around. You can just put the object ID directly inside of that field to represent the place ID. But for more complicated scenarios, where you want to reference, for example, cross database or cross collections or cross tables, then you need to have the so-called DB refs. So basically, you're specifying multiple fields, the reference, collection, the ID of the object, and the database you are referring to. But this would be for more complicated use cases. Question?
If the object that's being referenced is deleted, is there a kind of cascading or any back propagation?
Excellent question. Yes. So the question is, what if, say, this document is being deleted, and would this have some cascading policies as we have, for example, in relational databases? The answer is no. That's why I was mentioning on the first page. So it's called referential integrity in that case. So the referential integrity is not guaranteed. So the referential integrity is not enforced by the document by MongoDB. That's why you've got to be very careful when you are doing all kinds of operations. It's on you. And that's why actually the official recommendation is that if you can nest, you don't reference. So if you can nest your documents, you don't create references. But yeah, in the case where you have to, then you need to handle the referential integrity yourself. That's a trade-off. Computer science, no free lunch. Alrighty. Okay. Any remaining questions? Nope. So the last topic I'd like to briefly touch upon is the comparison between key-value stores and document stores. Technically, as Jislang has always said, document stores is just one type of key-value stores. It's true to some extent, but there are actually different use cases for different types of databases, and same here. So for key-value stores, the main difference here is that the objects or the key and the values are typically opaque objects. So basically there are black boxes having no structure to the database. So they are black boxes. So you can't do index on your values, right? You can't do search. Basically, it doesn't have any meaningful metadata. Say this key-value stores, for example, I'm using AWS to back up my phone. Then I would just back up my image or something like that, and it's a blob or binary object to the database. And for querying options, so for key-value stores, it's nothing but simple key-based lookup, right? Oops. But for document stores, as we've just seen, you have a lot more query options compared to the key-value stores. All right, but I have added a bit more information here, and you can look at it offline in terms of data structures. They're using the schema flexibility that we just talked about, data relationships, queuing indexes, use cases, stuff like that. But yeah, just FYI, if you're interested, have a look at it. Yeah, for doing the exam questions, you just, I think these are the two most important factors you need to consider based on your application. Okay. Already, that's all I'd like to cover. Let me check my list. Yeah, so that's all I'd like to cover in this session, and any remaining questions at this point? Hello. Any questions about the system design or the references we've just talked about, the queries? And yeah, especially for the prefix matching, I will get back to you guys in terms of why it doesn't benefit for certain queries. But yeah, any remaining questions? Yeah, question?
I don't really like MongoDB by the looks of it.
Right.
I'm wondering why it's so popular. Like, the whole syntax, I don't like it.
You mean you mean the JavaScript API?
Yeah, the JSON syntax.
Okay.
Doesn't make much sense to me.
Right.
And also, like, the architecture seems,
Yeah,
I'm not sure.
I see. Yeah.
Why do you think it's so popular?
So if you don't like MongoDB, then you're not alone. but you are against a lot of people then, because most people like JavaScript. I don't. And I think, yeah, so getting back to the question, jokes aside, I think the main reason, again, is simplicity. Like the startup time for me, like getting my hand dirty with MongoDB is almost zero. And you don't need to change your underlying infrastructure or your application in order to use MongoDB. It's basically a drop-in option for most companies, and especially for companies having large legacy code base, they don't want to change much, and MongoDB really is the no-brainer or the go-to option you can always have. Because it doesn't have any restrictions on the operations you can have. You can kind of know however your application is structured, it will work. But as I said, there's always a trade-off. So it doesn't really give you the kind of maintenance you want. It's kind of messy, so most companies don't use it for really critical data. It's mostly for the data lake or the data layer. You want to just put your data in and do some analytics sometimes, but not very crucial stuff. But I think your point is well made.
Even like the semantics of like the filters, it just doesn't really make much sense to me at all. Just, I don't know.
Agreed. Yeah, that's all I can say. But yeah. If you're going outside, people ask you, do you like MongoDB? Yes. But yeah, I have to say there are lots of downsides, but I think simplicity is really a good thing in real world scenarios, and it really saves a lot of manpower sometimes. Yeah. Good question. Any remaining questions? Nope. Okay, then I will stick around and I will push the notes to my repository. Feel free to check it out, and just raise your hand if you have any questions about the lectures or the exercises. And please make sure that you check out the repository of the notebook in the repository and practice with some queries. Although you wouldn't be asked to write queries yourself, but you need to know the syntax and the expected outputs as you do for the HBase stuff. Okay, that's it, guys. Thanks a lot.